Dear student, today we are going to recap of Unit 2 explainable AI with the real-time example. Okay, but not in a dry theory way. We will connect it with a real-time example that you already know from your day life, right? So before starting, tell me one thing. When an AI system give an output, do we always trust it blindly? No, right? So that is why unit is very important, this unit. Okay, as the slides show that explainable AA. So today we will today we will revise the four major concepts. First one, anti-hoc explainability, post-hoc explainability, interactive machine learning, and then beta models. So don't worry if the names feel heavy. By the end of this class, you will feel these concepts are very simple. Okay, let's go one by one. Okay, listen carefully. AA is longer, okay, no longer just a lab concept, right? So these are the models we will show: anti-hoc explainability, post-hoc explainability, interactive machine learning, beta models. Okay, why explainability is needed? Okay, so AI is no longer just a lab concept. So AI directly affect a human life. Exactly right. AI directly affect the human life. For example, a loan rejected. Okay, a loan get rejected. A disease is predicted. A student is marked as the risk. Okay, so now imagine you are the person affected. So naturally, the first question you will ask is, why this output? Why I am rejected? Why this diseases? Why am I marked at a risk? Right. So these questions are naturally asked. Okay. So main, why this output? Right. So if AI says, suppose, okay. Suppose if AI says the loan rejected and gives no reason, okay, will you accept it? No. Okay. So we need trust, fairness, accountability. Okay. So that is the where explainable AI come. Have you got? Okay, now very important concept: black box model, transparent model. So black box model, you give a input and you get the output. Okay, you give a input, you get the output, but you don't know how the decision was made. Okay, in a transparent model, you can clearly see the logic. Here also the same, you give a input and you get a output. Okay, but you can clearly see the logic. So why the decision was made? Fine. So you understand why the output also came. So think like this: black box equal to sealed pressure cooker. Okay, sealed pressure cooker. So transparent equal to, it's a open kadai. Okay, so it's a funny one, right? So explainable AI also try to reduce the black box behavior, right? Have you got it? Okay, now let us move to anti-hoc explainability. Okay, so the anti-hoc explainability means explanation is built before the prediction. Explanation is built before the prediction. So the key ideas are: the model itself, it's a explainable, or it uses a simple rules or decision trees, so humans can easily understand it. Okay, for example, rule based system. Okay, the rule based system, we don't need extra explanation later, the model is already clear, right? Okay, students, imagine a hospital. Okay, this is an hospital scenario. A hospital, the doctor set a rule like, if a BP greater than 140, it will be a high risk. If a sugar greater than 180, it will be a high risk. So now AI follow these types of rules. Okay, so why does the doctor trust it? Because the rules are very clear. and the doctor knows exactly why the patient is labeled the high risk. Okay, the doctor know exactly why the patient is labeled at high risk. Okay, this is an anti-hoc explainability. Have you got this? This is the real-time explanations of imagining a hospital system. Then next example. So another real-time example, loan eligibility. So rules. If income less than 20,000, it may be rejected. If a CIBIL score less than 650, it also may be rejected. Right. Now the students tell me, is the decision is transparent? Yes, I capture your mind voice. Yes. So even the customer understand the why loan was rejected. That is the power of anti-hoc model. Okay, have you got it? Okay. So anti-hoc model where it is suitable. So the models are used to easy to audit, easy to explain, used in the government scheme. Okay, used in the government scheme. Best for the simple problem. Okay, so but remember, not suitable for very complex data like a image or speech. Okay, so it is easy to audit, it is easy to explain, it is used in the government scheme, best for the simple problems, right? Okay, now come to the post-hoc explainability. Okay, it is just opposite that anti-hoc. Okay, it's just opposite that anti-hoc. So post-hoc means the prediction come first, the explanation come later. Okay, the prediction come first, the explanation come later. So when we have used this type of models post-hoc, because the model is too complex. Okay, the model may be too complex and the logic also hidden. It's not a transparent. So the deep learning is involved. So these type of conditions when we used here post-hoc explainability. So post-hoc explainability is prediction come first, explanation come later. Okay. Here the explanation is approximate. So not exact, right? But still useful. Got it? Okay. Imagine a bank. Okay. Post-hoc real-time example. Imagine a bank system. AI monitor the thousands of transaction. Okay, AI monitor the thousands of transactions. Okay, so it detect the fraud instantly. Okay, it detect the fraud instantly, but the logic is too complex. No, so what does the postcard do? It give a reason like it is an unusual amount, it is a strange location, it is an ad time. Okay, so the bank officer, okay, use this explanation to confirm this is an fraud. Okay, this is a fraud. Okay, have you got it? The another example. Okay, now the healthcare example. So AI, okay, scan the MRI or CT images. Okay, so it predict the tumor first, then show the heat map. Okay, it predict the tumor first, then show the heat map. So the doctor look at the highlighted region and verifies. Important point, student. AI support the doctor, not replaces them. AI support the doctor, not replaces them. That is a post-hoc explainability. Okay. Hope you got it. That is a post-hoc explainability. Move to the next slide. So why PHE is popular? Post-hoc explainability is popular. It is a high accuracy model. Okay, it's a high accuracy model used in a vision and speech. Used in a vision and speech. It improve the trust. Okay, it's a common in deep neural networks. Okay, so even though the logic is complex, explanation help humans, right? Then interactive machine learning. Okay, already we studied. Okay, now let us move to the interactive ML. So human interact with the AI. Okay, the feedback is continuously given. The feedback is continuously given. So the model improve the step by step. The model improve the step by step. Okay, the human always stay in the control. Human always stay in the control. Okay, so the IML real time example. Okay, I'll show you. Simple example, spam email example. So the AI predict the spam. The AI predict the spam. So it user marks a spam or not. It user marks a spam or not. Okay. The feedback goes to the model and then the model update the immediately. Okay. So that's why the spam detection keep improving daily. Fine. Got it? So AI predict the spam and the user marks spam or not. Feedback goes to model. Model update immediately. Okay, the real-time example of IML, okay, recommendation system, okay. So YouTube or Netflix. So you like or skip videos, okay. The AI track your exact behavior, okay. So the recommendation may be changed. Suppose you are watching some comedy movies, it may be the recommended, it's a comedy scenes, okay. You watching a thriller movie, the recommendation may be a thriller movie, okay. It is a learning app. Okay, the track the wrong answer, adjust the difficulty and student learn at the own space. Okay, that is the interactive learning. Okay, have you got it? Education. In education department, the learning app track the answer and wrong answers are identified. Okay. Track the answer, wrong answer are identified. Difficulty levels are adjusted. Okay. Difficulty levels are adjusted and the student learn at the own pace. Okay. Then AI adapt to the learner. AI adapt to the learner. Now come to the final concept. Original model is black box. Okay, the transparent model is created separately. It mimics the black box behavior. Okay, main purpose for auditing, compliance, explanations. Okay. We will see the real-time example. Okay, beta loan and autonomous car. Okay, the loan, the neural network approve the loan, the decision tree explain us why, the manager justify the decision. Okay, whether we will be give a loan or not. Okay, the autonomous car, it will show you the autonomous car, which means the self-driving car. Okay, so the self-driving car brakes suddenly. Rule explain obstacle distances, so the passenger feel very safe. Okay, these are the beta models. Okay, have you got it? The another comparison, AHE, BHE and IML and then beta. Okay, so AHE is a rule based system. What is that? AHE is a rule based system. PHE, post hoc explainability, it is a medical image explanations. And then IML, the user feedback learning. Okay, then beta, the audit and compliance. So the model chosen by when the time required. So the final conclusion, the explainable AI build the trust. So it is essential for the safety system. So it is different models at a different task. So the ethics require the transparency. The explainable AI is a feature. Okay. Thank you, students.